Hey everyone, welcome to this particular module where we're going to start talking about how to use prefix lists in concert with distribute lists to filter our RIP traffic. Now, what we need to realize here is that we need a prefix to work with. Now, what I'm going to do is I want to do pretty much, we'll start very coarse instead of very fine. So what we do know is that R22 in our data center is learning prefixes from both R2 and from R3. And it's going to be all the prefixes that are actually being learned on all of their individual links that they're advertising to us. So right now, if I come up and pick any interface, just do a trace route to 11, 11, 8, 11, I'm going to be load sharing and I'm going to be actually traversing both R2 and R3 as I send my data through my infrastructure. Now what I want to do is I want to modify this, and I'm going to do my modification on the basis of performing filtration. So here's what I'm going to do. I no longer want to receive any updates from R3. So that means every prefix that I'm going to learn, I want to learn from R2. And any other device that I may be connected to. Right now I only have the two, but I want to illustrate how we can use a distribute list with regard to our routing process, not just an individual interface, to be able to do filtration. And we're also going to do it in concert with this idea of how we configure our prefix list. So what I'm going to do is I'm going to use a distribute list with a prefix list. Now the prefix list gives me some advantages. It gives me the capability of being able to support or sort on a network or a range of networks. Also, using the distribute list, I can also specify something called the gateway. Now, the prefix is going to be the networks that I want to perform filtration for. The gateway is going to be indicative of the source or the via field whereby I learn those prefixes. Let me take myself out of the equation here and let's illustrate that. So show IP route. Let's just pick one, 11, 11, 8, 11. And what this is corresponding to, this would be the prefix. Excuse me, this would be the prefix. This would be the gateway. So what we see here is we have two gateways. We have 2, 2, 3, 3, and we have 2, 2, 2, 2 that we're learning from. Now, like I said, I no longer want to learn prefixes from R3. But I want to learn every other prefix in my infrastructure from every other device that I'm going to be advertising information to me. So what I'm going to do is I'm going to create not an access list, but a prefix list. And that prefix list is going to allow me to match the traffic that I want to work with. The first prefix list that I'm going to create is going to match the gateway of R3. Well, actually, that'll be the second. The first one is going to be, what networks do I want to learn? Well, I want to learn all networks. And to learn all networks, or to use an access list, or a prefix list, excuse me, to define all networks, all I do is I type IP prefix list, and I'm going to say all networks. Once I've got that, I'm going to give it a sequence number. Say sequence 10, and I'm going to say permit, and then I need to define what I'm going to permit. Well, I want all networks. Well, this is a representation of all networks, 0, 0, 0, or 0.0.0.0/0. Now, the other value that I want to be able to specify here is that it's going to be any network. So this is the actual binary value, but it's going to be any network less than or equal to 32. So that's going to match every prefix that I could possibly be interested in my topology. And I'm going to use that for all networks. Now the other part of the scenario is I need to match the gateway that I don't want to learn prefixes from. We said that was going to be R3. So here's the form that's going to take. What I'm going to do is I'm going to say IP prefix list, and I'm going to say except underscore from underscore R3. Sequence 10, and I'm going to say deny, and the identity of that device is going to be 10.1.223.3/32. I'm going to match it exactly. But the thing is I've still got this idea of an implicit deny now. So what I'm going to do is I want to permit everything else. So I'm going to say IP prefix list except from underscore R3 sequence 20 permit 0/0 less than or equal to 32. So now I have two IP prefix lists that I can work with. I have the one identifying the network, and I have the one with two lines identifying the particular device that I want to deny traffic for. So let's take a look and see what happens when we apply this and how we apply it. Router RIP, distribute list, prefix. Now notice I'm going to specify the prefix that's going to identify the networks that I want to learn. Well, I want to learn every network there is. So I'm going to say all networks. Then I'm going to specify my gateway. So I'm going to say except from R3. So I'm going to say gateway, paste, except from R3. And I'm going to do this in. And if I specify an interface, it's going to do it on the basis of that interface that I specify, which means it's going to make it very, very granular. But if I leave the interface off, it's going to look at it from the perspective of information coming into the routing process. So let's leave that exactly the way it is. So right now what I'm going to do is I'm going to come up here and say prefix list, all networks, gateway, except from R3 in. Now let's see what happens. So we know R3 is connected to serial interface 2/1. So show run, show IP route, pipe include via, we'll just do 10.223.3. Now notice what's happening here. All of my timers have exceeded 30 seconds. They will quite literally exceed 1 minute, which they already have. So now we see that every interface or every prefix we're learning on serial 2/1 is expiring out of our table. Let's look at everything else that we have. Show IP route 11.11.8.11, and let's see what we've got. Well, right now we have R2, which we're learning the prefix from, and R3, which we were learning it from, but we haven't received any refresh information. So now, see what we have. Show IP, or let's go ahead and clear the process. Clear IP route star. Show IP route for 11.11.8.11, and now I only have the one interface, serial 2/0, which means now that route is going up to R2, and from R2, it's going to be traversing my infrastructure. Let's find out what path it actually takes. How do we do that? Trace route. Trace route's a handy, handy tool. So trace route to 10 or 11.11.8.11. Notice it went from R22 to R2 to cat1 to R1. Now, the point here is if I should lose this connection, config T, interface S0, or S2, one, no, 20, shut. Do show IP route 11.11.8.11 or 0. Notice it's no longer going to be in my table. It's no longer going to be in my table because I have written a clause, a policy that says I'm not going to ever place anything that I learned from this particular gateway into my routing table. So what I've done is I've created a situation where I had failover, but now if I lose a link that I'm currently up and operational for, I cannot fall over to the other one because the distribute list is going to prevent that prefix from ever being installed in my routing table. So as you can see, it's a handy tool, but it has its drawbacks. So before I forget, I want to do a no shut. Show IP route, RIP. Let's just wait for it. We should start learning prefixes here shortly. Show IP route, RIP. Nothing yet. Show IP interface brief, exclude assigned addresses, up, show IP route RIP. Still nothing. Show run section router. Prefix list, everything's still in place. Show IP route. There we go. Again, it's just an issue of being patient. So now again, trace route 2, 11, 11, 8, 11. And now I'm load sharing, not load sharing, I'm just going straight through R2. R2 to cat1 to R1. So this illustrates how I can use my gateway command in concert with my prefix in order to be able to not just take out entire sections or entire networks, but I can actually specify networks that are being advertised from specific, I don't want to say neighbors because it's RIP, but specifically from other RIP speakers based on the IP address on the link with which I'm connected to them. This could come in very, very handy if I had many devices connected over, say, like an Ethernet connection, and I wanted to reduce the amount of information being exchanged across my link. So again, basically it just drives home the point that we have lots of tools that allow us to be able to do filtration and removing prefixes from our routing tables. So let's continue this conversation because there's still other tools, and we'll talk about those in the next video. I'll see you guys there. Bye-bye.